Guys, this here is Tuesday. So what we're going to be doing is starting today, we're going to start going into different gas laws. So the way that it's going to work is we're going to introduce you to the gas law first, give you a couple practices, and then after that, tomorrow we're going to do some actual work, but I'm going to go through it myself and try to go through some of this information. So what I have so far on my reading assignment is I have the Boyle's law. And it says if temperature of the amount of gas is constant, doubling the pressure decreases the volume by half. So he gave us a graph with the volume in liters and the pressure in ATM. And then it showed us how it changes. When the ATM goes up, the liter of gas goes down. Okay? So when we're doing Boyle's law, what you really need to know is this right here. P1 times V1 equals P2 times V2. P is pressure, V is volume. So the practice problem tells us that a diver blows 0.75 liters, okay, that is how much volume, in a 10 bubble 10 meters under the water. Don't care about where he was. As it rises on the surface, the pressure goes from 2.25 atm to 1.03 atm. What is the volume of the bubble in the surface? So the first thing we're going to do is we're going to say, all right, here's my equation. P1V1 equals P2V2. And I am trying to get V2 by itself. So I rewrite the equation. If I want V2 by itself, if I divide both sides by P2, that takes that off of there. So then the next thing I'm going to do is I'm going to put in my information. P1 is 2.25 atm. My volume 1 is 0.75 liters. And then my P2 is 1.03 atm. So in my calculator, what I'm going to do is I'm going to go in. I want to make sure you can see the calculator. I'm going to go in and I'm going to say, all right, so I have alpha y enter. I have 2.25. I'll do an open bracket, 2.25, close bracket, open bracket, 0.75, close bracket, down, and 1.03 over and enter, and I get 1.63838. So it's 1.6 liters, right? Because ATM and ATM is off, and that is my answer for that question. So let's look at the new problems. It says the volume of gas is at 99 kilopascal. Okay, so let's go over this information first. When we're talking about volume, we want to make sure we have liters. But when we're talking about pressure, our pressure can be, and you have, if you write this down every time and start memorizing it, you'll be okay. 1 atm equals 760 millimeters, of mercury equals 760 torr equals 1.103 point, and that is kPa. So let's look back where I got that from. I got that back from when we did our reading from the other day. So I'm going back to my reading. So where did I have that? 1 atm, 760 torr, 760 meters of mercury. And then where's my 1.103 point for 101.3 kilopascal? So it's 101, sorry, 0.3 kilopascal, 760 torr, 760 millimeters mercury, and 1 atm. Okay, so now let's see what we've got. Volume of gas is 99 kilopascal. Well, that's up here, isn't it? So that is going to be my pressure, right? These are my pressures. So pressure 1 equals 99 kilopascals, okay, kPa. and has a 300 milliliters of air. So that means my volume 1 equals 300 milliliters. But I need to change my milliliters to liters, right? So I'm going to have to change that in a few minutes. If the pressure is increased, so my pressure 2 equals 188 kilopascal, what is my new volume? Volume 2 equals question mark. All right, so I know there is 1,000 milliliters in 1 liter. So if I take that number with my calculator, and I said 300 times alpha y, enter, 1 liter, and there is 1,000 milliliters in, 1,000 milliliters in a liter. And so that tells me that it is 0.3 liters. Okay, now P1 V1 equals P2 V2. I'm looking for V2 this time, so I'm going to divide both sides by P2. If I do that, there's my new equation. So then I'm going to plug everything in. So I've got 99 kilopascals times 0.3 liters, right, over 188 kilopascal. And when I get done, I should have liters. So let's see. Alpha y, enter, 99, open bracket, 0.3, close bracket, down 188, and I get 0.15797872234, which would be 0.15 liters, right? So that would be 0.16 liters. And if I wanted to change that, I personally would prefer still to have 0.158. Excuse me, 1.158. And that is liters, is my answer. Okay, so that is question number 1. Question number 2 says that the pressure of the sample of helium, the pressure of the sample of helium is 1.00 liters. Well, that pressure, so if I'm looking for it, is this the pressure of the sample, the pressure of the sample helium is 1.00 liters, so that's my volume 1, 1.00 liters, and then my ATM, which is my pressure 1, equals 0.988 ATM. What is the new pressure? So I'm looking for pressure 2, okay? If the sample is in a 2.00 liter, and that is my volume 2. So I'm looking for P2 now. So what I'm going to do is I'm going to do my formula again. P1 V1 equals P2 V2. I'm going to get P2, so I'm going to divide both sides by V2. And that means 0.988 ATM times 1.00 liters divided by, and that's going to be my 2.00 liters. And when I get done, I should have my answer in ATM. So, alpha y, enter. I've got 0.988. Let me make sure. Yep. Open bracket, close bracket, 1.0, and then 2.0. And that's going to equal 0.494. So that's 0.494 ATM. That's my number 2. So number 3 tells us there is air trapped in a cylinder filled in a piston that occupied 145 milliliters. So that is my volume 1, which I'm going to actually change that, right? So we did milliliters before. So that when we changed milliliters before, we did 145.7, open bracket, alpha Y, enter, 1 divided by 1,000. I'm going to delete that because I'm going to put my close bracket, and I get 0.1457 liters. Okay, and at 108 atm, that's my pressure one. What is the new volume? So my volume 2 is what I'm looking for. If the piston is depressed, increases the pressure by 25%. Okay, so if it was 1.08 and we multiply, and we're going to actually increase it by 25%, we're going to times that by 0.25. I get 0.27. So that's 1.08 plus 0.27, which would give me 135. Pressure 2 equals 1.35 atm. So based on that, I'm looking for volume 2. So I'm going to do P1 V1 equals P2 V2. If I look back, I'm looking for V2. So since I'm looking for V2, I'm going to divide both sides by P2. Okay, my P1 is 1.08 atm. I'm going to multiply that by my V1, which is 0.1457 liters. And I'm going to divide that by my pressure 2, which is 1.35 atm. So that's going to be alpha Y, enter. So that would be open bracket 1.08, close bracket, open bracket 0.145, close bracket down 1.35 over, enter, and I get 0.116. And so I'm going to go ahead and say that it's 117, and I am looking for pressure 2, so that, volume, so I'm going to say that's liters. And that's my answer.